everyone, it's Martin here to talk to you today about observability predictions for 2022. Before we get started, just a little bit about myself and my background. Historically, have worked at bigger tech companies like Microsoft and Amazon in the cloud infrastructure space. So at AWS, I was a tech lead on the EC2 team and really transitioned over to the observability space when I joined Uber, where I led the core observability team. And our mission there was to really help Uber transition from their traditional monolithic application on VMs to a microservices architecture on containers, which perhaps today is known as cloud native architecture. And as we were helping Uber through that, we realized that a lot of their existing monitoring, logging, and observability solutions were not really, the ones that we were using for the old architecture weren't really well suited for this new cloud native architecture. So that was really the problem we solved for Uber, and we did that by building a lot of new tools. So things such as M3 for metrics and Jaeger for distributed tracing. And we're using those tools, and we open source those tools to really solve the observability problem at Uber. More recently, left Uber a few years ago to co-found a company called Chronosphere, where I'm currently the co-founder and CEO. And we are in the observability space. In fact, we provide a hosted SaaS observability solution. You can imagine helping companies like Uber transition over to cloud native architecture as well. And our product is built on top of a lot of the technologies that we had created while we were at Uber. But it's a little bit about my background and where a lot of the sort of domain comes from. You can imagine both being a practitioner before and now at Chronosphere, sort of helping a lot of companies with their observability challenges is where a lot of these predictions come from. So with that, I will go into the three predictions we have for 2022 in the observability space. And the three of them are that open standards reach critical mass. The second one is that centralized observability becomes the norm. And the last one is that data, and in particular observability data, that growth reaches a tipping point. So those are the three predictions we have for 2022. And we'll just dive into each one here, one after the other. Cool. So the first one we want to talk about is open standards reaching critical mass, and what does this mean? So a trend that we've been seeing recently in the past few years is that companies have been more and more moving away from a proprietary approach to observability. And what we mean by that is proprietary instrumentation, proprietary solutions. And there's a few reasons why a lot of companies want to move away from that more to a open source based or open standards based type of solution. The first one is that with a proprietary solution, there's actually a pretty high cost to switching. And the reason is that with a proprietary instrumentation, proprietary sort of tooling, you're fairly locked into that one piece of technology. So if you want to switch one out for another, there's actually a very heavy lift in both replacing all your instrumentation, replacing the tooling on the back end, and replacing all of the sort of knowledge base built from your end users on that tooling. So it's actually very expensive to switch between solutions, and that's a pain point that a lot of companies out there identify pretty quickly. More and more so, the other thing that's pushing the industry this way is that it's really easy to get started in open source these days now. So if you think about the modern cloud native architecture, and everything is built on top of Kubernetes, most of the things in that ecosystem are already come pre-instrumented, and they already come pre-instrumented in an open source standard. So if you think about metrics, everything is already pre-instrumented in a Prometheus format already, and it's one standard open source format. Or perhaps for distributed tracing, it's all instrumented in open telemetry. So there's a lot of I would say the community is just a lot more mature and integrated with these open source standards than ever before. And that didn't used to be the case. And not only that, the actual tooling itself, a lot of that is open source as well. So, if you wanted to get going and start to monitor something, you could just run Prometheus. It's a single binary solution. You can get that up and running really quickly, and you have sort of out of the box monitoring there. Same for distributed tracing with a tool like Jaeger here. And not only are these tools speaking the open source standards, but they're also the sort of standard open source tools to get started with as well. So it's just a lot easier these days to get started with open source and have the ecosystem around that as well. And then the last one here that we hear from companies is that often when you have a proprietary tool, it's much harder to find new engineers, new developers to join your company, whether in the observability or SRE team or just general teams outside of that. We often find that most folks in the industry more and more so are skilled and trained up on the open source standards and the open source tooling versus a proprietary one. So if that is your stack, it's much higher chance to hire somebody who's already been familiar with that and they don't have to ramp up with it already. So these are some of the trends that we've been seeing in terms of why people are moving towards open source and away from sort of proprietary. And as I mentioned earlier, the sort of and our sort of prediction this year is that it sort of reaches critical mass in the sense that it's past the point of almost no return here now. So, as I mentioned earlier, Prometheus is the standard metrics protocol and standard tool that companies use. And along with that tooling, PromQL is becoming the standard query language. Grafana dashboards are becoming the standard dashboarding, Prometheus Alert Manager, et cetera, right? So all of these are sort of becoming the industry standards here, and those protocols and how end users interact with them are also becoming standards. And same with OpenTelemetry on the distributed tracing side of things. And we see this sort of, you see on the bottom right here, this balance of power and at least data acquisition and data production is really swinging over to the more open path and a path where the customer or the company controls that data as opposed to a vendor, because it is in a format that is now universal. And you can imagine if you instrument your applications in these particular protocols, you can actually not lock yourself. You don't have to lock yourself into a particular vendor. And you can actually switch between any of them that you want. And I think for this year in particular, what we're seeing is that more and more proprietary vendors are now seeing this trend and having to respond to it by also adding support for these open source protocols. So our sort of recommendation here for folks that may be in an observability team or an SRE team is that if you are going to pick a new project to instrument and how to sort of pick the protocols that you want to go with the open source standards, because those are the ones that protect you the most from vendor lock-in. That is the one where there's most community development and the industry is moving towards anyway. So that's sort of the safest choice there. And that still leaves you the flexibility with going with both open source, running it yourself, or vendors that support these open source protocols, or proprietary vendors as well. So that's sort of our recommendation that comes along with this particular trend that we see for this year. Cool. Switching gears a little bit, the second prediction here is that centralized observability becomes the norm. And what we mean by this is, if you think about perhaps historically, observability or monitoring, perhaps in larger organizations in particular, perhaps were siloed to their lines of business or to the business unit themselves. So what we often find is one particular business unit inside a larger company has their own set of tools and processes that's unique to just that business unit. And you can imagine that's different across all of the lines of business in that particular company. And there's some challenges with that type of approach. The first one is that often, even inside these lines of businesses, there's multiple tools. So it's not even a single tool. So you can imagine even inside one larger organization or one larger team, there's already multiple tools. You may have some tools for IT and monitoring to look at your network or your underlying infrastructure. You may have a different tool, like an APM tool for your applications. You may have a different tool for perhaps the business data there. So it's already a sort of combination of different tools, and generally they don't work well together and they have different interfaces, because most of the time these are proprietary sort of tools with custom interfaces, custom query languages. So you can imagine, even as a developer inside of one of these teams, switching from tool to tool is already fairly difficult. You can imagine that's just for one line of business. So if you have multiple lines of business, each of them have different tools and different processes, which it just means that there is really no consistency across a company at all. And that brings up its own set of challenges. The second thing with that is that it's really hard to get a global view across everything. You can imagine with the different tools, that means the data is dispersed amongst different tools in different departments. And to get a more holistic view or overall overall view of a business is fairly difficult in this siloed approach of things. And finally, we find that each of these tools come with, and each of these lines of businesses have their own teams that manage and run these tools. And often those teams are solving the same problems again and again and sort of reinventing the wheel. So there's a lot of perhaps waste there or inefficiencies there. So, we've historically seen a lot of organizations structured this way and think about sort of observability, or at least monitoring, APM, and infrastructure monitoring in this particular siloed approach. And what we think is going to happen moving forward, and we already see this in sort of newer organizations, is that observability becomes centralized instead. And generally, this is being driven by a central observability team, or perhaps a central SRE or DevOps team. And that team really, they have a few main responsibilities, right? The first of which is defining the standards and best practices for observability, ideally across the whole company. And these standards and practices include things that we talked about earlier, includes things like the instrumentation libraries and the protocols, so things like using the Prometheus protocol and Promcure being the standard for metrics, or OpenTelemetry being the standard for distributed tracing. But it sort of goes beyond that even. So, you can imagine defining that is at least a start there across an organization. But you can imagine sort of defining things at a higher level there, and not just defining them. So, for example, things like what an SLO means or what an SLA means across an organization. SLOs are great tools to have, but if each team has a different meaning for it, or have a different way of measuring that, that seems to break down very quickly as you sort of go across teams and things like that. So sort of defining higher level things outside of just the instrumentation and the protocols are really part of those standards and best practices. And even taking that perhaps one step further, in the sense that not just defining and telling folks how to do it, sort of doing it on their behalf. So often we find that central teams can actually get into, let's say, the microservices scaffolding and start to produce automated instrumentation in terms of perhaps latency, error rates, and things like that, so that when a developer goes and creates a brand new application, they get that level of visibility for free out of the box. So all of that, we see as part of the responsibility of that central team, but also you get a lot of sort of benefits from having a central team do that across the whole company. That consistency across the whole company benefits hugely. So you can imagine if you're an engineer in one team in one line of business, and you're sort of trying to interact with or look at a dependent service that's owned by a different line of business, it is fantastic if you're able to query that data is in the one place, and you're able to query it, let's say, using the same query language, and everybody has the same definitions for what they mean by their SLA guarantees for their downstream services and whatnot. And all of that is consistent. It just makes everything so much easier. The second one here is that this central team generally, ideally, provides a single set of tools for observability, and this goes back into the having different tools with different interfaces is a bit of a disadvantage, especially because often what we find these days in modern cloud native architectures is that the issue isn't just in one part of the stack. It's actually a combination of multiple services running on different types of infrastructure, or different clusters, or perhaps infrastructure in different zones and things like that. So the view of the infrastructure and the application and the business, and having ideally that data in one single place, and having one set of tools on top of that, there are a huge amount of advantages around it. The last two here is sort of the third one is supporting varying use cases. So you can see here we have an example of particular different requirements from different teams, and sort of the one the other side of having a central system means that you need to be able to have that single system support all of these varying use cases. So perhaps, you can imagine some teams have very high cardinality use cases, some teams have different retention or scrape interval requirements or whatnot, and a lot of those have to be fulfilled by this central team. And then the last one here is sort of ensuring the reliability and the accessibility of this tooling. And again, this is on the other side of centralizing everything, is you need to make sure, now that there's a dependence on a single set of tooling, you need to really make sure that it is highly reliable, and especially when it comes to observability, because this is the system that is telling, is telling the rest of the company how the infrastructure is running, how the applications are running, how the business is running. So it's almost, this is mission critical. This is a mission critical piece of tech, or part of an infrastructure stack that needs to be almost the most reliable piece of that stack. And then accessibility is more the fact that now that all of these different end users in different teams and different lines of businesses are attempting to access this single tool set or single solution, ideally they get fair access, right? So you want to avoid things where perhaps one individual or one team accidentally creates a script and starts, accidentally putting too much load on the system. You want to make sure that that is limited just to that single team and doesn't really impact the availability of this overall observability solution to the rest of the teams and the organizations. And that's a big job of that central team. So what we see is that, again, coming back to the prediction here, of sort of seeing this centralized model as opposed to a siloed model sort of become the norm for organizations moving forward, while speccing out some of the responsibilities of what this central team will do. And sort of, our recommendation here are these things that this team will do, and then sort of, going beyond just providing the tooling, right? It's so much more than just providing the tooling. It's the standards and best practices that can really be rolled out across an organization, and having consistency there is hugely beneficial. So that is the second prediction. The third one here, switching gears again, is that data growth and observability data growth in particular reaches a tipping point. And what we mean by that is, if we look at how the growth of the sheer volume of observability data is growing over the years, and not just over the years, as companies transition their architecture from perhaps on-premise to a VM-based cloud architecture to a cloud-native architecture, what we generally find is that the pace at which the observability data is growing is far faster and far outpacing the pace at which just the general business is growing, or perhaps the infrastructure footprint is growing. And if we want to take a specific smaller example of that, you can imagine perhaps a few years ago, folks will be running their applications on VMs, and now today on those exact same VMs, you're running a Kubernetes cluster. You're trying to go cloud native, right? And you've broken up that application into microservices instead, and you're running those on the containers on the same cluster. Now, your infrastructure footprint and your bill for that cluster doesn't really change that much. The cloud providers don't charge you that much to run Kubernetes on top of the underlying VMs. You're really paying for the underlying VM. So your infrastructure footprint hasn't changed very much. With the same cluster size, you can imagine you're pretty much serving the same business use cases. So your business perhaps hasn't changed very much. Now, with this new cloud native architecture, there's a bunch of advantages with it. Of course, you can imagine you can deploy multiple times a day, and that architecture is generally a lot more reliable. So there's a bunch of advantages with it. But one of the sort of unfortunate side effects of that architecture is that it produces a lot more data. And if you just think about why that may be, now you have tens of containers running on each VM. And if you think about monitoring a container, it's really the same amount of data that you would need to monitor a VM, because a container still emits its CPU usage, memory usage, disk usage, etc. Right? So it's the same amount of data each container requires as a VM. However, there's tens of these things running on top of every VM. And then on top of that, they're very ephemeral. So they're changing all the time. And every time they change, it's a brand new container. So you can just imagine the sheer amount of data that produces. Again, on the same infrastructure footprint, it's so much more data there. Moving up the stack a little bit, same thing with your single monolithic application, and now it's broken up into tiny microservices. Each microservice emits, I wouldn't say the exact same, but the rough same order of magnitude of data as the original application, and now you have a lot more of those as well. So you can see very quickly how adopting this architecture results in so much more data being produced. And the downside of this is, generally, as that data volume starts to grow, generally the cost of the observability system rises in a pretty correlated manner, because you can imagine either you're running these observability systems yourselves, in which case more data means more hardware to these systems, which increases the cost, or you use a managed vendor for your observability solution, and all of the vendor solutions out there also charge based on the volume of data in some way, because you can imagine underneath the covers they also have to store all of that data, and that's sort of their cost model. So what we generally find is that cost rises are pretty correlated with the rise in observability data, and what that ends up meaning is that the overall cost rises, but also the relative cost of observability to your infrastructure is so much higher now. So we often find when we talk to companies now is that maybe in the infrastructure bill, maybe observability is like number 2, number 3 on that list, and it's growing very quickly. And I'll say that if that was the case and companies were getting more value out of it, so if the observability data was growing and companies were getting far better visibility into everything, that were sort of reducing their time to repair or time to detection, I actually think companies would be fine with that, because you get the value with the cost. But what we're seeing is that that's not the case. What we're seeing is that the data is growing at this pace and the cost is growing, yet people aren't getting better value. In fact, often when we ask people and companies, what is your mean time to detection or your mean time to repair, those are often getting worse. So it's almost like you're paying a lot more for something and getting less return on that particular investment. And that sort of disparity is something that we believe is going to reach a tipping point, in the sense that it's going to force companies to do something about that. So if you look at that problem a little bit, and I'll take a second to dive into each of these perhaps approaches to solve that data growth problem. But the overall approach here to solving this problem is really to understand the outcomes. And by understand the outcomes is really by inspecting the data itself and understanding what you are using this data for, and optimizing the data for those use cases instead. And more concretely, here are perhaps 4 techniques that can be used to go help with this data growth. So, I'll start with the 2 in the middle here, the retention period of the data and the resolution. So, a concrete example may be, I imagine most systems, whether you run it in-house yourself or use a managed vendor, there is one set retention period for all of your data. And generally, I believe that's set to about 13 months or so, which means every piece of data that gets produced, no matter how you want to use it, is retained for 13 months. Now, that may be useful for some pieces of data, but especially in the modern cloud-native architecture where we're deploying multiple times a day and a container is only around for a couple of hours, a huge amount of the modern observability data does not need to be retained for 13 months, especially not to the full level of detail. So, you can imagine instead, if you're tracking, let's say, the CPU of a particular pod, and you have that down to the unique pod ID level, there is no need to store that. In fact, it's quite a waste to store that data for 13 months. You may want to just store that data for a day, let's say, and then perhaps you do want to sort of store some amount of data over time for capacity planning, trend analysis, and whatnot, but it's never down to the per pod level. You're probably trying to store that across a cluster, across a particular set of services or something like that. You can imagine changing the retention period of that subset of data from a year, 365 days, down to a single day is going to have a 365x reduction in the amount of storage that you need, right? So retention is one way to go and optimize the data, but it's not just sort of setting the retention across all of your data. It's sort of understanding for each use case, for each subset of the data that serves those use cases, what is the optimal sort of retention period there. Very similar for resolution as well. You can imagine by resolution, we're really referring to what is the size of what is the frequency by which this data is being emitted. So am I tracking the CPU every 10 seconds versus every minute versus every hour? And depending on the use case, perhaps if you have a CI/CD type of use case, you're doing automated deploys, tracking it every second or 10 seconds makes a lot of sense, because you need to know in real time, very quickly, what is happening with your CPU so that you can perhaps roll back a deploy or roll back a particular change. However, there are going to be other use cases out there where, again, maybe capacity planning or long-term trend analysis, where actually you don't need that data down to the per second basis. And often what we find here, just like like retention is people just use the defaults, and the defaults are going to be somewhere between 10 seconds and a minute. And really understanding some of the sub use cases here and optimizing the data in terms of setting the resolution for that use case, again, helps a lot, because you can imagine if we're measuring every 10 seconds versus we measure every minute, there is a 6x difference in the amount of data that needs to be produced and stored there. So, those two are two ways we can optimize the data based on the outcome and based on the use cases. The one on the right here, I'll cover, and then I'll come back to the first one. So the last one here is efficient storage. And by efficient storage, what we mean is a lesson we learned at Uber, is that a lot of this data for observability is time series data, which means it's a measurement of something over a period of time. Now, when you have that type of data, putting that type of data into just your general object store or a key value store is hugely inefficient. Generally, you want to have a data store that's optimized for this type of use case. So, using relational databases or key value stores or blob stores are not the most efficient ways to store this data. And really what you need is a storage solution that's built and purpose-built for this type of solution. So generally, those are time series databases. And actually out there, if you look at most of the open source solutions or the proprietary vendor solutions, most of them are actually not backed by time series storage technologies, which is interesting for sure. So there's definitely a lot of efficiencies there just in how we even store this data, because it's a particular type of data, a particular type of use case there. And then the last one that I'll touch upon here, but this is perhaps the most effective one as well in dealing with data growth, is data aggregation. So this is a very common pattern or problem we see when we talk to companies out there, where they're emitting a ton. And this is in particular for metric data, but this can be applied to other data types as well. Is that people generally emit a ton of data, and the data has a lot of dimensions on it, and it makes a lot of sense, because you do want to slice and dice your data by those dimensions at a certain point in time. So, you can imagine when you're looking at a latency, you don't just want to see the overall latency of an application. You may want to break it down by the latency between your various clusters or your various data centers or regions and things like that, and compare those. You may want to break down the latency by the types of users that are requesting this particular service there. You can imagine there are many ways that you want to slice and dice this data, because when something goes wrong, you want to use that slicing and dicing to pinpoint what is it really affecting, where is it going wrong. So it's these dimensions or pivots are hugely advantageous for folks. Yet you can imagine they also produce a lot of data, because for each different pivot you have, it produces so much more additional data. And what we find is that a lot of this gets produced. So there's a lot of these pivots, and all of the pivots are generally on all of the data. However, when people go to read this data, so you can imagine perhaps you have, let's say, a million unique pieces of data that you are producing, because it's the combination of all of these pivots. But when you go to read the data, nobody ever actually reads all million. Like, it's actually impossible for a human to process a million lines on a graph. So what often happens is that as we're trying to read the data, we're doing something to it, we're transforming it or aggregating it before it becomes human consumable, right? So, perhaps we're doing a sum or an average across all of that data set, or we're picking the P90 of that data set, something that's going to reduce the data set down to something that is more human readable and understandable, and reducing the data set. And what's interesting is that, there's a huge amount of data that gets produced, and there's a little bit that gets read. What's interesting is that we know exactly how you're going to read the data, because you can imagine users have configured their dashboards and their alerts to know which views of the data they're interested in. And if they don't have a dashboard or alert for it, they're generally not interested in the other views of the data that weren't created, right? So if you knew the views of the data that you want, this is another way to optimize for the outcome. Is if you always want the sum of this data, you can't emit it as a sum, because you have to emit all the individual components, because no individual component knows the sum of all of this data. But if you only ever want the sum, what you can do is pre-calculate the sum as the data is coming in, and only store the sum, right? So you can imagine you only store the final answer, which is generally a much smaller data set, and much more efficient to store, and just throw away all of the raw data if you should choose to. And that approach also has a side effect of ensuring that the subset of data that does get retained is a lot faster to read, right? Because you're actually just reading the pre-computed answer already, as opposed to computing the answer, this very expensive answer, each time you go and read the data. So there's a bunch of benefits there, but that is yet another way of understanding. It's the same thing. It's understanding the use case of this data and optimizing it for those particular use cases here. So I guess to summarize that a little bit, it's, we see that this data growth is going to reach a tipping point in the next year, and companies are going to have to figure out how to deal with it. And our recommendation is this sort of outcome-driven approach of dealing with the data. So yeah, so those were the the three predictions that we had for observability in 2022. Just to sort of repeat them again, the first one's open standards reach a critical mass, and here is where we see that the open protocols and the open source tooling become the sort of de facto solutions there. And our recommendation to folks, especially on the instrumentation side, is to adopt those. You can't go wrong by adopting those and instrumenting in those formats, because even if you then choose to go with a proprietary vendor, they will have support for those particular protocols. The second prediction is that observability is really going to become centralized, and that's going to become the norm. And again, our recommendation there is to sort of support that centralized model, but also it's not just the tooling and having a single tool. It's also the processes and the best standards that can be created in almost a bunch of the sort of the instrumentation perhaps and the dashboards and whatnot can be pre-created for folks as much as possible in a fairly consistent manner. And then the last one here that we just covered was that data growth and observability data growth in particular reaches a tipping point, and we predict that most companies will have to go deal with this in one way or another. And there are a bunch of sort of techniques there, specific techniques to go do so, but it's really about understanding the use cases and optimizing the data for the particular use case. So those are the three predictions that we have here. So thank you all for listening to that. And if you're interested in keeping this conversation going or have some thoughts on these particular predictions or the observability space, feel free to tweet at me at my Twitter handle there or email me at my email address. And also separately from that, if you're interested to learn more about how Chronosphere as a company thinks about these problems and what we are doing to tackle these, feel free to check us out at chronosphere.io. But yeah, thank you everybody, and hopefully we'll chat to you soon.